We've already learned about the method of elimination and the method of substitution for linear systems. So how do you choose the best method when you're trying to solve a system of equations between those two? Well, if one variable is already completely isolated, you're going to choose substitution. So if I look at these two equations, equations 1, equation 2, I've got y already isolated. Oh, that should be an x there. Let me fix that. All right, so y is already isolated. It's very easy to use substitution here because I can take equation 2, I can take this y right here, and since this other side is equal to y, this piece right here is equal to y, I can just replace this y. I'm going to take that out and replace it with this piece in here that was in the box. So substitution is easy there. I can put equation 2 right into equation 1. So that's how to know when you should use substitution, if you've got one variable already completely isolated. If all variables have coefficients or the coefficients already match, then elimination is easiest to choose. For example, when we look here, the x's do not match, but the y's do. We have one positive 7, one negative 7. The y coefficients already match, so it would be really easy here to just add the two equations and eliminate the 7's or the y's would eliminate right there. Let me point out that it doesn't matter which one you choose. You will always get the right answer no matter which one you choose. And you might already be thinking, if I get to choose, I'm always choosing substitution because that's easier. I always want to do substitution, and that's fine. But at this point, we still need to practice both. So if you're wanting to do substitution, you get a question like this, I would isolate this x. All you have to do is bring the 7y over, and then you could do substitution here as well. So that would still work. You have one extra step, that's all. But substitution will always work, elimination will always work. These are the steps which I'm not going to go over. These are all the steps for substitution, and these are all the steps for elimination. And in previous videos, I've gone through all of those steps. So I encourage you to go back and look at those steps again, or print this off or make copies so that you have them. So there's the way we can decide which one to pick. This example we're going to do, solve the linear system. Remember, solve a linear system means find a point of intersection. We've got two lines here, and we'll have to first decide which one we're going to use. So substitution, I think, is a little easier than elimination. So let's see if we can do that. Do we have one variable already completely isolated? Yes, we do. So let's do substitution here. So the first step I'm going to do is 2x minus 1 is equal to y. So I'm going to put it in here for y because I want the y's to equal each other. The y's are equal at the point of substitution, the point of intersection. So if this is equation 1 and this is equation 2, I'm going to sub equation 1 into equation 2. So equation 2 now looks like this. 3x minus, always use brackets when you're substituting so that you don't mess up these signs, equals 5. So here's why I need the brackets. I have to distribute the negative in. 3x minus 2x plus 1 equals 5. Now my next step is to subtract 1 from both sides. And these are like terms, so I'm going to put those together. 3x minus 2x is x. These are gone. They make 0 equals 5 minus 1 is 4. So I have x minus 4. Remember, you're not done. The next thing you have to do is take your answer and sub it back into one of the equations, whichever one you like. So let's sub x equals 4 into, what equation do you like better? Let's pick, let's pick 2. It's actually a little harder maybe, but we'll put some work into this one here. So 3x, equation 2 is really 3x minus y equals 5. But instead of x, I've got to put a 4 there. Minus y equals 5. This gives me 12 minus y equals 5. So I need to subtract 12 from both sides. That gives me a negative y, so these turn into a 0. And 5 minus 12 is negative 7. So to isolate y, I have to get rid of the negative in front, so I'm dividing both sides by negative 1. Y equals 7. The question said solve a linear system, so the solution is, therefore, you could write the point of intersection, but this question didn't use that vocabulary. It said the solution. So the solution, which is the point of intersection, is x is 4 and y is 7. So once again, there are our two methods, substitution and elimination. And let's look at our next example. We have two parts to this one. So let's look at part A first, solve each system. Okay, what do you want to do, substitution or elimination? So notice that these y's are exactly the same. The coefficient in front of them is an invisible 1. One is positive and one is negative. So that's a good candidate for elimination. If all variables have coefficients, or if coefficients match, choose elimination. So I could choose substitution, of course, I could do that, but we're going to practice both forms here. So let me choose elimination. I'm going to add both these equations together. So we add 2x and 4x makes 6x. So we're always adding down, right? Negative y plus y, they are eliminated. There is 0. And 2 and 10 is 12. Next step is to isolate x, divide both sides by 6, and I get x equals 2. That was pretty fast. When you look at the math that we just did there is not much math. There is not a lot of work shown. So even though elimination, sometimes students think it's more work, it can be a little more complicated here when you're multiplying equations by 2 or by 3. But if they already match, it's really fast. So I have x equals 2, but I don't know what y is yet. So we're going to sub x equals 2 into which one? Let's sub it into equation 1. That is, equation 1 was 2x minus y equals 2. So my x is a 2. That gives me 4 minus y equals 2. I'm going to bring the constants over, subtract 4 from both sides because that 4 was a positive 4. That gives me negative y equals negative 2. And again, we've got a negative in front of the y. We have to get rid of it by dividing both sides by negative 1. And that gives us y equals 2. So our POI, therefore, point of intersection is the x value is a 2 and the y value is a 2. And let's look at part B. What do you want to do for part B? Substitution or elimination? Remember the first step for elimination is the equations must be arranged in order. They are kind of in order. We've got the y's lined up, the x's lined up, and the constants lined up. But it's a little complicated because we have the y's match here, which makes me think, well, what about elimination? They match. Both are positive, so we would need to do some work. It's in order, but it's not in the order that we really need to make this easy. So I'm going to skip elimination on this one, and I'm going to try substitution. Both y's are isolated, so I could pick whichever one I want to put into the other. So let's take this y value here, which is 2x plus 3, and sub it into that y. So instead of y, I'm going to put 2x plus 3 equals x plus 4. Now I'm going to collect my x's. I want the x's on the left, so I'll subtract x from both sides to get rid of the x's that are on the right. 2x minus x is x. And these are gone. So now I need to collect my constants, and I get x equals 1. Okay, x equals 1, now we have to find y. So I'm going to sub x equals 1 into, I'm going to sub it into equation 1. That gives me y equals 2x plus 3. But instead of the x, I'm going to put a 1. y equals 2 plus 3, y equals 5. So for this one, my POI, my point of intersection, is x is 1, y is 5. The last thing I want to do here is check each of the questions with left side, right side. So when I check, I'm going to go to the equation that I didn't sub into. So here I subbed it into equation 1. Now I want to check this with the other one. I want to check with equation 2 this time. So check with equation 2. I'll put it up here. So I'm going to check 2 in equation 2. So I'm going to write out the equation for, this is equation 2, 4x plus y equals 10, but I'm going to put a line through my equal sign and a line across here. And I'm going to, now it's a left side, right side. So now I have a left side and I have a right side. So I'm ignoring this equal sign now. Right side. Go up to my left side. My left side is 4x plus y. And for y, I'm putting in a 2. Whoops. And for x, I'm putting in a 2 as well. Move all that over. 4 times 2 plus 2. That gives me 8 and 2, and that gives me 10. And my right side, of course, is a 10. So 2 is good. Now let's check the other one. I'm going to check 1, 5 in, so here I used equation 1, so I'm going to sub into equation 2. Equation 2 was y equals x plus 4. Turn that into a left side, right side. So my left side is actually y and my right side is x plus 4. So here's my x, here's my y. The y is 5. X is 1 plus 4. X is 5. So this one is right as well. We've checked both answers and they both work. You only have to check if the question says check. If it doesn't say check, then you could stop when you get here. You don't have to do the extra step, but of course, you have extra time on a quiz or a test. I recommend you do a check. It's worth it.